Okay, dear students, today we shall discuss the interconversions and problems. So, in that interconversions, first one interconversion is, let us start with the simple compounds. Convert ethane into ethene. So, this is the process of conversion of an alkane molecule, saturated molecules to alkene molecules, unsaturated molecules. How we can convert? So, whenever this type of the questions are there, basically you write down the molecules what given. CH3 single bond CH3 ethane molecule to be converted to the CH2 double bond CH2 ethene molecule and the reagents which are to be used. So, here double bond is there between the two carbon atoms, here no double bond, means we need to create a double bond between these two carbon atoms in order to get the ethene molecule. So, some elimination is required. So, after elimination only we will get this molecule. But to eliminate hydrogens we cannot eliminate directly. So, that we have to introduce some other substance which will be helpful for our elimination process. So, initially a substitution reaction is required, then elimination reaction is required. So, let us see the solution for this. Ethane molecule, you subject this ethane molecule with a bromine in the presence of sunlight. 1 mole of the bromine, use only 1 mole of the bromine. So, that you will get the CH3, CH2, Br. Ethyl bromide we got it. This is the step 1. This particular one is step 1. Whenever arrow mark changes, it is called a second step. So, in second step, what we use is, we use the alcoholic KOH. What is the use of the alcoholic KOH? It actually removes the one hydrogen and halogen from the adjacent molecules, so that we can get the CH2 double bond CH2 ethene molecule. This is the way we have to get it. So, whenever you want to convert the alkane molecules to the alkane molecules, always go for the halogenation process, then elimination process. Apart from the halogenation, you cannot convert the alkane molecules to the alkene molecules. The reason is, alkanes undergo only free radical substitution reaction with the halogens. These are a simple reaction. Now, let us see the second question. Ethene, convert ethene into ethane, means reverse process. Whatever we got here, that molecule, means we are converting the ethene means alkene to alkane. So, just write down the initially required compound ethene molecule to be converted to the ethane molecule. Sorry, I have to write down the molecular form, no? So that it is CH3, CH3 ethane molecule. So, what are the reactions and reagents required? It is very simple thing that you need to convert this pi bond to a sigma bond, and here the difference is extra 2 hydrogen atoms are there. So, simple thing is, solution for this is just you reduce it. CH2 double bond CH2 to CH3 single bond CH3. This is always possible only by using the hydrogen in the presence of nickel or platinum or palladium and heat it. Heating is always required. So, only this is the step to be converted alkenes to the alkane. This is just reduction process. Now, let us see another conversion, third one, that is ethane into ethyne. Just means alkenes to alkynes, or alkanes to alkynes, alkane to alkyne. So you write down the initial concept, that is CH3 single bond CH3. It is an ethane molecule to be converted to the ethyne, that is acetylene. So what are the required steps here? As I said in the earlier case here, a saturated molecule to be converted to the unsaturated molecule. Then what are the things required? Initially substitution followed by the elimination. So for every one elimination we will get the double bond, a pi bond. So here 2 pi bonds are required, so that 2 elimination are required. So that let us see here how to convert this particular molecule. Solution. So initially means we have to substitute one bromine here, one bromine here, but with a simple bromination it is not possible. I will show you. CH3 single bond CH3. When you subject with only 1 mole of the bromine in the presence of the sunlight, only one hydrogen will be removed. So that we will get the CH3 CH2Br. Then you may ask the question, sir, what happens if you use the 2 moles of the bromine? So that H nu. If 2 moles of the bromine is used, you may get this type of the product, CH3 CH Br Br, or else you may get the two bromine atoms on both of these carbon atoms. So all these molecules are able to produce the required alkyne molecule. So I am going in a different way. So initially I will subject with the alcoholic OH this molecule, alkyl halide, so that we get the CH2 double bond CH2 ethene molecule I am getting. This ethene molecule again you subject with the bromine in the presence of the CCl4, means I am explaining the more steps here. So here this is the substitution process, here this is the addition process. So here we get the CH2 CH2 Br and Br, this molecule. So this molecule again you subject with the sodamide directly, NaNH2. So when you subject with the sodamide, which is a strong dehydrohalogenating agent, directly you will get the alkyne molecule, or else you may follow the another step, that is alcoholic OH. If you subject this molecule with alcoholic OH, as I said earlier in the theory discussion, alcoholic OH is able to remove only one hydrogen and halogen like this. So bromine and hydrogen from this particular carbon and halogen, hydrogen from this carbon and halogen from this carbon. So once they are removed, a double bond will be developed between those two carbon atoms. Now this is called as the vinyl bromide. And this vinyl bromide cannot react with alcoholic OH, means alcoholic OH is inefficient to remove one more mole of the alkyl dehydrohalogenation, means hydrogen and halogen from the vinyl bromide, because here bromine lone pair of electrons participate in the resonance. So that alcoholic OH is inefficient to break this partially double bonded bromine carbon bond. Hence again we need to use the sodamide, which is an efficient reagent, even removes the hydrogen and halogen from the resonance molecule, so that we get the ethyne. So this is the better way, and from here also you can get this molecule, same step, that is NaNH2, and from here also you can get the same molecule, again NaNH2. Then you may ask the question, how NaNH2 removes this one? Because I'll write down this one as like this. You just see one hydrogen here, one hydrogen here. First one hydrogen halide, next one hydrogen halide. So all these are possible reactions in order to get our required ethane molecule from ethane molecule. So you must be careful in selecting the reagents whether they are helpful or not. Means it is indirectly these interconversions are the revision of alkanes, alkenes and alkynes to some extent, not completely, because we need help of the some other lessons also. Afterwards we will learn the more interconversion reactions. Now ethyne into ethane means simply alkyne to alkane. So you just write down the molecule required. This is ethyne, means reverse process we are following now. Ethyne into ethane, CH3 single bond CH3 ethane. So what are the things required here? It is very simple thing. By seeing the molecules itself we can understand that this is unsaturated molecule, this is saturated molecule. So unsaturated molecule can be converted to the saturated molecule just by reduction process. So solution is, take ethane molecule, means acetylene, subject it to the hydrogen in the presence of the nickel heat. This heating is always nearly 300 degrees centigrade, means generally high temperatures, because which are required to break all these bonds. So here we will use the 2 moles of hydrogen. So that CH3 single bond CH3 is possible direct conversion. And in this particular case you cannot use Lindar's catalyst, palladium, barium sulfate plus acidified quinoline. So if you use this one, this is also reducing agent, it reduces alkyne to only alkene. Even if you use sodium liquid ammonia or lithium liquid ammonia, they also reduce alkynes to alkenes, not to the alkene molecules. So that's why be careful while selecting the reducing agent whether you want the partial reduction process or complete reduction process. So fifth one. Now let us see ethene into propene. So ethane into propene means this is actually if you see the reaction, means the molecular forms, this is ethene, this is propene. So number of carbons increased. So whenever number of carbons increased, that type of the conversions usually called as ascending series, ascending in alkene series. So we are just converting this one. Then in this particular case we have to develop one carbon-carbon single bond. Then which are helpful reagents, and we need to search for all the reagents that are available in our notebook. When you are perfect in solving the questions, then you will be able to understand this, how to overcome this particular process, because this conversions gives a overall idea about the complete reactions what we learned. So you just see how I am converting alkene molecule. So whenever this type of extra things are there, you need to go for unsaturated molecule to be converted to the saturated molecule. Then only elimination or substitution is possible. So you just substitute, add one hydroiodic acid or hydrobromic acid, so that we get the addition CH3CH2I. This is the key molecule. This step is key. Without this step, means you can use the HBr or HCl or HI, whatever it may be. So either you can use HI or HBr or HCl, any of these can be used. But I selected HI. The reason is iodine size is more, easy to eliminate, easy to remove. If a bromine is there, it becomes a bit difficult. If chlorine is there, still becomes difficult. So that preferably select for the iodine, which can easily be removed. So this one, when subject with the R. Gilman's reagent, lithium dimethyl cuprate. I had very clearly discussed about this reagent in our class, that this reagent is able to provide the CH3 minus ions. Organometallic compounds usually produce the carbon ions. So this particular carbon ion attacks over this methylene group, means iodine group, iodine halogen bearing carbon atoms, and replaces the iodine, so that we get the CH3, CH2, CH3. Now this particular molecule, when subjected with the bromine in the presence of the halogen, because now our required compound is developed, means length of the carbon is developed. Now we need to develop the again double bond. For double bond, this unsaturated molecule, so that bromine halogenation is required, so that this bromine can be substituted to either primary carbon or secondary carbon. Both are there, so that you just take both the molecules. So here CH3, CH, Br and CH3. This is the major molecule. Even percentage calculation also we did. And CH3, CH2, CH2, Br. Now these molecules is just subject to the alcoholic KOH. So take the hydrogen from here and halogen here, so that we get the CH3, CH double bond CH2. Here also, if you take alcoholic KOH, hydrogen from here and halogen from here, again you will get the same molecule CH3, CH double bond and CH2. Apart from this, you can go for another method, that is methyl iodide in the presence of the sodium diether. So what is the name of this reaction? The name of this reaction is Urge reaction. But this reaction is not a preferable thing. Why? Because Urge reaction generally do not give the pure products when used with different alkyl halides. So that even if you use just only possibilities we are discussing here. So we got the propane molecule again. So from the propane means remaining steps are same. Okay. So from here same steps we need to follow, or else you can use the halogenation. Here we use the bromination, halogenation, and same steps are to be used. Apart from that, even nitrogen compounds we did not discuss so far, so that it may be difficult for you, but you are the second year students, so that if you are the second year students, then you can easily understand this one. Just subject this alkyl halide with the potassium cyanide. You must remember, these are all using Urge reaction, using Gilman's reagent, using potassium cyanide. They all helpful in developing the carbon-carbon bond. A new carbon-carbon bond will be produced. So that here, if you use potassium cyanide, this negative cyanide part will attack over the halogen bearing carbon, replaces the halogen, and we get CH3, CH2, Cn. I think you got it now. Carbon-carbon bond is developed. Here also carbon-carbon bond. Here also carbon-carbon bond developed. So these cyanides are to be reduced to the amides. So you can use the lithium aluminum hydride, which is a reducing agent, converts the cyanides to the amines, so that you will get the CH3, CH2, CH2, NH2 amines. So these amines, when subjected to the HNO2, this is a very careful reaction. You must remember that HNO2 reaction with primary amines, secondary amines, tertiary amines, it differs. HNO2 differs, will give the different products when amines category is changed. With the primary amines, HNO2 gives the alcohols. So this NH2 part will be converted to the alcohol. So that CH3, CH2, CH2, OH, alcohol is produced, propyl alcohol. So this propyl alcohol, when subjected with the two methods, again I am going to two methods, just subject with the PCl5, alcohols with phosphorus pentahalide they are HCl, they give the CH3, CH2, CH2Cl, alkyl halides. You might have learned that ethyl alcohol react with the PCl5, give the ethyl chloride. But here propyl alcohol we are using. So afterwards use the simply alcoholic KOH, so that you will get the propene molecule. Or else from here direct step, that is concentrated sulfuric acid. So when you use the concentrated sulfuric acid, there is a loss of water molecule, hydrogen from here and OH from here, so that they will be removed and we get the alkene molecule. So these are all possible steps. Anyhow, this video will be shared to you. So whenever you require, you can see the video so that your doubts will be clarified. Now let us see another reaction. Propene into ethene. So propene means, here I'll write the molecule first. CH3 CH double bond CH2 to ethene, CH2 double bond CH2, which is helpful, means number of carbon atoms are reduced, but both are the alkene molecules only, so we call it as a descending analkene series. So here we discussed how to develop a new carbon-carbon bond and what are the possible reagents that are helpful. Many are there, only few we discussed, but in coming lessons, after knowing the some other reagents, then you will come to know how to develop the new carbon-carbon bond apart from these reagents. Now in this case, reactant molecule is having 3 carbon atoms, product is having only 2 carbon atoms, means we need to reduce the number of carbon atoms. That's why it is called the descending series. So whenever there is a need to reduce the number of carbon atoms, always opt for the ozonolysis. So ozonolysis always gives the breakage of the bonds. Generally ozonolysis means oxidation. So like that you can opt for the general oxidation process. So here I will take the ozonolysis first. Initially propene molecule subject with the ozone in the presence of the H2O, first step. Second one is zinc H2O, I am giving directly, means ozone H2O we mentioned, ozone zinc H2O. We are not using any oxidative ozonolysis, it is a reductive ozonolysis. So you must remember while selecting this one, we have discussed even oxidative ozonolysis also in our lesson, alkene lesson. If you have any doubt, you can open that video and see that reactions. So when reductive ozonolysis is used, just break this double bond, add one oxygen here, one oxygen here, so that we get the CH3 CHO aldehyde plus formaldehyde we get. That formaldehyde I am not considering because our required molecule is this one. So this particular molecule you just subject to the lithium aluminum hydride reduction. So aldehyde part will be reduced to the alcohol, CH3 CH2 OH, alcohol molecule. So this alcohol molecule, this ethyl alcohol molecule, use concentrated sulfuric acid. Whenever ethyl alcohol you are using, you must be careful while selecting the temperature. It must be 170 degrees centigrade. Then only dehydration within the molecule takes place and gets the alkene molecule. 170 degrees centigrade means within the molecule. We have already discussed this reaction many times, even though I am just using this particular time even to elaborate the concept. Use the concentrated sulfuric acid. So when 110 degrees centigrade is used, but all these reactions are dehydration reactions only. So when 110 degrees centigrade temperature is used, you see CH3 CH2 OH plus sulfuric acid, I am writing like this, H HSO4. So water molecule will be eliminated like this, and final product is CH3, CH2, HSO4. This is called as ethyl hydrogen sulfate. Okay. So now if 140 degrees centigrade temperature is used, then water molecule will be eliminated, means dehydration process takes place from two alcohol molecules. So H2O like this, so that you will get the CH3, CH2, oxygen, CH2, CH3. This is called as the diethyl ether. But when 170 degrees centigrade, means when you are raising the temperature, you can see only alcohol molecules are participating. Initially acid and alcohol participated, now two alcohols participated. When 170 degrees centigrade temperature is used, then dehydration takes place from only a single molecule, means hydrogen from here and OH both will be eliminated like water, and finally we are getting the alkene molecules. So in this particular reaction, we did certain things, that initially we reduced the number of carbon atoms. Okay. Afterwards, based on the functional group we obtained, we have selected our reagent. Then we got another molecule, because here aldehyde is there, but our required molecule is alkene molecule. So this aldehyde is to be converted to the alkene, means directly it is not possible. Even when you subject this molecule with the that reagent, Wittig reagent. If you use the Wittig reagent here, number of carbon atoms will increase. But Wittig reagent with a formaldehyde, you can get this molecule again. I will show you that reaction also. H, C double bond O H. So that Wittig reagent CH2 double bond P. So aldehydes can be converted to the alkenes directly by using the Wittig reagent. But here we are considering this one as a byproduct, we are considering this one as the main product. You can take formaldehyde as a main product to convert the molecule like this. So these are all possible options in order to get the alkene from the means ethene from the propane molecule. Let us see the next one. Seventh molecule is acetylene into propane. Okay, means again it is a ascending series. This is acetylene to be converted to the CH3 C triple bond CH propane. Again there is a need to develop the carbon-carbon bond. But for carbon-carbon bond developing process, see what type of reagent actually we are having. This is a terminal alkane. So when terminal alkynes are there, you no need to search for a different reagent, just to subject this terminal alkane with sodium or sodamide, whatever it may be. So sodium, when used, this terminal alkane will be converted to the sodium alkanide. This is sodium acetylide. So monosodium acetylide, when subjected with the methyl iodide, it can easily be attacked over this alkyl halide, and finally we get CH triple bond C CH3. This is propane. A simple reaction, how to convert the alkyne, how to increase the length of the alkane chain. This we had already discussed. And eighth reaction is let us convert propane into acetylene. This is a descending series. So propane means actual opposite process we are following now. CH3 C triple bond CH, propane into CH triple bond CH. So in this particular molecule conversion, we have to reduce the number of carbon atoms. At the same time, we have to maintain the triple bond also. So just to see how to convert this one, you take this propane molecule and subject it to the Lindlar's catalyst, palladium, barium sulfate or calcium carbonate. Remember always this one, both in quinoline combination with acetic acid. So what is the use of this particular reagent? It converts the triple bond to the double bond. So just you see CH3, CH double bond, CH2. Alkene molecule I have got. So after this alkene molecule, when you subject to the ozonolysis method, I haven't selected ozonolysis here. I'll discuss that later. So here we have got this ozonolysis process, and now we can reduce the molecule like this, CH3, CHO means aldehyde. So this aldehyde, maybe aldehyde ketones lesson you might have studied that when it is subject to the PCl5, PCl5 removes oxygen always, so that two halogen atoms will be introduced over to the carbon, so that CH3, CH, chlorine, chlorine. You will get this ethylidene chloride. So this ethylidene chloride on reaction with the first step with the alcoholic KOH, second step with the sodamide. You must understand why I am using these reagents, because already the interconversions are explained. If alcoholic KOH is used, one hydrogen, one halogen will be removed, so that we get the vinyl halide. So vinyl chloride alcoholic KOH is not helpful to remove one more hydrogen halogen from the vinyl halide. Hence we are using this strong dehydrohalogenating agent like sodamide, or else directly you can use the sodamide, and the final molecule is CH triple bond CH. So in this particular process, the use of this conversion of this alkyne into the alkene is to reduce the number of carbon atoms by ozonolysis. Even we can select this particular method directly when you subject to the ozonolysis. Ozone H2O. So this ozone H2O generally converts the CH3, C double bond O, COOH. So this just heat it. Generally heating is not required, but when you heat it, it will be converted. This carbon dioxide will, COOH will lose the carbon dioxide. You no need to use some other reducing agents, or else if you want to use the soda lime. NaOH plus COO, soda lime, which is decarboxylating agent. Okay, so that CO2 will be removed and we get the CH3 COOH. So we got the carboxylic acid. This carboxylic acid, so much of lengthy process is involved. On reaction with the lithium aluminum hydride, we get the alcohol molecule. So this alcohol molecule, if you subject with the PCl5, only one halogen will be substituted like this. So from here many methods are there. Subject with the PCl5. Then we get the CH3, CH2, Cl. And this one on reaction with the alcoholic KOH. So we get the CH2 double bond CH2. So this one on reaction with the Br2CCl4, then you will get the CH2Br and CH2Br, and now this is again alcoholic KOH, first step, and the second step is NaNH2 sodamide, so that we get the acetylene molecule. Or else from here again you subject this one to the some oxidizing agent, palladium barium sulfate. Palladium barium sulfate, if you use it, it will oxidize. This means Rosenmann's reduction, sorry. You should not use this one. That is acid halides to the aldehydes. So if you use any oxidizing agent like Ag2O, some mild oxidizing agents are chromium oxide, so you will get the alcohol will be converted to the aldehyde. So this aldehyde, again rest of the process is same. PCl5, you will get the CH3, CHCl, Cl, and this one with alcoholic KOH, second with the sodamide, then you will get the alkane molecule. So conversion of directly acetylene means alkyne to the ozonolysis means length of the procedure is more. That's why here the procedure is reduced. But these are all possible reactions. You can follow any of these reactions. Anyhow, this video will be shared to your email ID directly. You can check the reactions once again. And we have completed number of the reaction is 8th reaction. Okay, let us see the 9th reaction. One butane into 2-pentyne. So you just write down the reaction first. Butane, CH3, CH2, C triple bond CH. So you must be aware of the writing the IUPAC nomenclature. By giving the name, you must be able to develop the structure. This is 1-butane and pentyne, 2-pentyne they said, CH3, CH2, C triple bond C, CH3. So 1, 2, 3, 4, 5. So what is the things required? A very simple reaction. Just we have to increase the number of carbon atoms. That too here given one is terminal alkyne. So once a terminal alkyne is given, then our work becomes very easy, as we can convert this terminal alkyne just by subjecting with this sodium or sodamide. So we get this CH3, CH2, C triple bond C minus Na, and subject this molecule with, because we want only one carbon atom, so that subject with the methyl iodide. If you want the 2 carbon atoms, take the ethyl iodide. So that here you will get the CH3, CH2, C triple bond C, CH3. This is 2-pentyne. So in this way we can convert. Let us see 10th interconversion. 1-butane into 2-pentanone means ketone molecule. So write down the first of all given compound, so that you will get the idea. CH3, CH2, C triple bond CH to be converted to the 2-pentanone. 1, 2, 3, 4, 5, 2-pentanone. So what are the possible reactions required? Initially, the main difference between these two is here one extra carbon atom is there. So we have to increase the carbon atom. That too, the carbon atom is, if you increase here, so the terminal alkyne should not exist. So you see here CH3, CH2, CH, terminal alkyne is given, subject with the sodium. So we get the CH3, CH2, C triple bond C minus Na, and subject with the methyl iodide, so that it attacks like this, CH3, CH2, C triple bond C, CH3. Now this alkyne into the ketone. This was discussed very clearly in our regular classes. 1% HgSO4, 40% concentrated sulfuric acid, hydrolysis. So when you subject this hydrolysis, CH3, CH2, hydrogen one side, OH other side. Imagine hydrogen is here, double bond C, OH and CH3. So immediately it undergoes, this means tautomerism, because it is an enol. So that shifting of the bonds takes place. CH3, CH2, CH2, C double bond O, CH3. So ketone is formed. So dear students, hope you understood this particular interconversions. These questions you just copy and try to solve and send me the answers. So 1 minute, slowly I'll keep like this, and you can pause the video so that you can copy these questions. I'll put like this. So all these questions you can copy and try to solve these questions, and these answers and solutions for these questions will be discussed in the next session. Dear students, hope you understand today's lesson. So if you understand my explanation, like this video, share this video to your friends who are in need of these lessons, comment whether you understood or not, or whatever the things you want, and do not forget to subscribe this channel. Thank you.